Hey folks, Ben here with Steadybit. Let's take this opportunity to take a look at chaos engineering experiments with Steadybit, specifically to recreate a past incident that we have suffered. In our scenario here, we assume that the hot deal service has failed, and as a consequence, the gateway service was also impacted, meaning we did not have a nice service degradation, but instead a hard dependency and therefore an outage. And we want to verify whether that is still the case, so whether it can still occur, or whether we are now a bit better and safer. To do so, we create a new experiment by heading to the Experiment tab and hitting the New button. We start up with a blank experiment for now, and we operate in the development environment to test this. Of course, testing in production is something you can do as well. Just depends on where you want to start. We give it a name, Hot Deals Failure Impacts Gateway Service. And then we can start up with a blank canvas. This is basically like a film strip. So you can drag and drop sequences in that will then be executed as part of your experiment. And we want to establish first what it means that the gateway service is working. And we do so using a check. You may also be used to the term probe from other services. It's essentially the same. We want to verify that our gateway service is working, and we do so by issuing HTTP calls against it. Now I copy paste the URL and I configure what I want the check to do. In this case, I wanted to execute 1 call per second, and I wanted to do so for 40 seconds in total. And what it does is it will execute 1 call per second, and it will verify the response status code as well as the overall success rate. And if that success rate is not maintained, the experiment will be marked as failed. Next up is our actual container attack. We want to impact the hot deal service to simulate this outage. And there are a variety of ways to achieve this. We, for now, will choose a network black hole attack on the container. So we drag and drop this in, and you can also drag and drop in other attacks as well, like Kubernetes attacks, JVM attacks, and so forth. But we will use the container black hole. And the first step is telling Steadybit which container should be attacked. And we get some templates for this, so we just say, I want to choose those containers by the Kubernetes deployment. And I can select the cluster. Thanks through Steadybit's discovery, we get auto-completion for all of these values. And I can just say, okay, deployment name hot deals within the demo prod cluster in the Steadybit demo namespace. Cool. That results in total in 4 attackable targets. And as you can see, there are 2 different kinds of containers, hot deals and hot deals nginx. So that is good to know. Seems like we have 2 pods with 2 containers each. How many do we want to attack though? We for now want to verify a full outage. So we say 100% of those targets. Next up, we want to see the service working at least temporarily. So what we do is we add a wait statement before the network black hole attack to at least have a few HTTP calls succeeding just in case the service isn't working. We save the experiment and now hit run. The Steadybit agents will now be connecting to the platform in order to execute the experiment. The platform acts as an orchestrator for this purpose. The film strip has now got this indicator to tell where it is within the execution. And if we scroll down, we can actually see the HTTP responses from the call we're making. We can now see that it has changed. The black hole attack has become active. And we can also see that the HTTP calls are now failing. So it seems like we could still be impacted by the incident I talked about earlier. Seems like there's still some homework left to do, meaning we still have a hard dependency. We get information that we have a socket timeout actually. And we can even see that Kubernetes is starting to complain because the liveness and readiness probes of those hot deals pods are no longer reachable. And in the end, we can see Damn, the success rate is below our expectation. That's something we have seen as well, but it is useful for automation purposes in CI and CD. And while that is failed, we have learned something now. We have learned that we have still homework to do. We have still things that we need to improve in our system. The black hole attack was now reverted automatically by Steadybit. So this is nothing you have to worry about. A revert is always, at least when possible, an implicit part of the attack. Hope you found that insightful. See you later.